All right, so a couple people asked about challenge problems with the cup stacking thing, and I wanted to just give you a couple questions. And this is a little bit of a different video. I'm not going to show you how to do them. I'm just going to present the different questions that you could think about. So one challenge problem that I want you to think about that many of you saw is that there's not just two ways of stacking. You can stack them alternating like this, and that one was pretty easy to figure out how tall the stack was. You could also stack them so that they're nesting in each other like this, and then you can see that the slope is just the lip of the cup or the brim of the cup. Not so bad, you still have to think about it, but that one wasn't so bad. But many of you, when you stacked cups, stacked them like this. One cup, and then you made a stack like a triangle, and then you made a stack continuing to be like a triangle right there. So if you know that I am 6'3", and you know that each of these cups is 5 inches tall, how many cups would it take in a triangular stack to be as tall as me? That's one challenge problem. So again, I'm 6'3", each cup is 5 inches tall. You can stack them triangularly. You should be able to figure out how many cups it takes. A little bit of a challenge problem, but not too bad. Here's another challenge problem. It doesn't just need to be a triangle that you stack them in. Some of you had other, maybe more interesting three-dimensional shapes like this, where there's 3 cups on the base and 1 on top. And then from there, you can expand outward and add on additional cups to create a really strong tower like this. And so one other challenge question that you could have is, depending on how you create your towers, how many cups would it take to be as tall as me? So think about it. There's lots of different ways to stack cups, and depending on how you stack cups, you'll get a different answer for how many cups are as tall as me. One last type of challenge question that you might be interested in is comparing 2 different types of cups. So comparing, say, our styrofoam cups to our red cups here. And what I want you to notice is that the styrofoam cup is a little bit shorter than one red cup, but it has a bigger lip. So if I stack my styrofoam cups, each cup makes it taller by a bigger amount than by stacking my red cups. The slope for the styrofoam cups is bigger than the slope for my red cups. When I measured it, one red cup is 5 inches. Each red cup adds 1/4 inch. One styrofoam cup is about 3.5 inches, and each cup adds 1/2 inch. So if I write that information on the board, we have our red cups, where 1 cup equals 5 inches, and then the slope, each cup adds 1/4 inch, compared to the styrofoam, where we had 1 cup is 3.5 inches, and the slope, each cup adds 1/2 inch. So you could try to figure out when stacking one type of each cup each time, when those 2 stacks would be exactly the same. So those are some of the challenge questions that you can do in our unit right now of the linear patterns. You might even call them a couple of challenge problems.